Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 8, Lesson Number 2, More Work with Parabolas. Before we begin, let me remind you that you can find a copy of the worksheet that goes with this lesson, along with a homework assignment, by clicking on the video's description. As well, don't forget about our QR codes at the top of every page. Scan these with your phone or tablet, and you'll be brought right to the video that's associated with the lesson. All right, let's begin. In the last lesson, we looked at quadratic functions. Those were functions that could be rearranged in the form y equals ax squared plus bx plus c. And the key there is that it had to have an x squared term as its highest power. All right, today we're going to be looking at these functions more, understanding how the a, the b, and the c, but especially the a, affects the graph of the parabola. And let's jump in and look at another simple quadratic function without our calculators. So, the simple quadratic function, y equals negative x squared, is one of the most important ones out there, and yet it's quite tricky. So let's take a look at letter A. It says, write this parabola in the form y equals ax squared, where a is the leading coefficient, then fill out the table below. Now here's the key. Even though it's not written, we can think of this as negative 1 times x squared. Now, that's exceptionally important, all right? Exceptionally important. Because a lot of people will look at negative x squared and they'll think, okay, I should take the x, I should multiply it by negative 1, and then I should square it. But that actually is getting the order of operations incorrect. In fact, what we're supposed to do is take the x, square it, and then multiply it by negative 1. So for instance, right, when x is negative 3, we're going to square the negative 3, get positive 9, and then multiply it by negative 1 to get negative 9. Uh-oh, not a lot of room here. So I get the point negative 3, negative 9. When I have negative 2, right, I'll take that negative 2, I'll square it, I'll get positive 4, and then I'll multiply it by negative 1 to get negative 4, giving me the point negative 2, negative 4. Likewise, we'll just keep doing this. Keep plugging that x value in, squaring it, and then multiplying it by negative 1. All right. Even when we switch over to the positive x values, it really makes no difference. If I square 0, well, 0 is not positive, but then I'll get 0, giving me the origin, 0, 0. If I square 1, I'll get 1 times negative 1, which will give me negative 1. So I'll get 1, negative 1. All right, negative 1 times 4 gives me negative 4. And finally, and I miss those calculator tables right now. Now, notice, right, just like what we saw before when we had parabolas in our last lesson, we've got some symmetry. Negative 1, negative 1. We've got, let's go with a different color, green. Let's go negative 4, negative 4. Why don't we go black on our last color, negative 9, negative 9. So we're still getting that great symmetry that shows up in parabolas, but let's plot this thing. We've got negative 3, negative 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, we've got negative 2, negative 4, 1, 2, 3, 4. We've got negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 4, and 3, negative 9. So we get this beautiful parabola that looks something like that. We didn't really have any parabolas in the last lesson that opened downward like this. So here's one that does it. You know, all the ones that we graphed in the last lesson opened upwards. Okay? Now the range, we keep talking about the range again and again and again, the range. Here, the maximum y value, note, is actually 0. That's the biggest y value. I know that seems weird, but it is. All other y values simply go down from that. So a great way of saying the range would be y is less than or equal to 0, or, if you wanted to use that interval notation, negative infinity to 0, including the 0, but not including the negative infinity. All right? Now I think it's important to have actually worked that one out by hand. We could have put it into our calculator. We could have used a table of values. But it's important that when you see something like negative x squared, that you interpret it as negative 1 times x squared and not negative x squared. These are very different, okay? All right, I'm going to clear out the screen, so write down whatever you need to. Okay, here it goes. Let's move on. Okay, now we're going to be breaking out the graphing calculator. I hope you brought it because we are going to use it a ton, and I'm going to show you a few things on the graphing calculator too that we haven't seen before. All right, what we want to be able to do is graph a bunch of parabolas pretty quickly and not using tables of values. We're just going to literally get the graph on the calculator screen, take a look at it, and then sketch it, okay? So we're going to open up the TI-84 Plus. All right, there's my calculator. We are going to go into the y equals, enter each one of these, but separately, okay? And then we're going to sketch them. But we're going to sketch them using the standard window. The standard window is one where the minimum x value is negative 10, the maximum x value is positive 10, the minimum y is negative 10, and the largest y is positive 10. Okay? So let's do that. Let's take the calculator. Let's hit y equals. All right. Clear out any equations that might be there. Okay. And let's put that first one in. Okay. So let's put in 3 times x squared plus 6 times x minus 4. As always, once you've got the equation in there, I want you to pause for a minute. I want you to look at it, make sure that it looks right. Okay. And now let's go in and change our window, and that's going to be the window that we're going to use for almost everything for the rest of the lesson today. So you're not going to have to worry about continually changing it. So hit your window button. Let's put in x min, let's put in negative 10. X max, let's put in positive 10. Go down a little bit. Y min, let's put in negative 10. Y max, let's put in positive 10. All right. Check your window. Make sure you got everything right. Otherwise, strange things can happen. All right. I think it looks good. Looks good. And now let's hit the graph button, okay? Graph. Okay. Now, all I really want to do is sketch that graph. It doesn't have to be the best sketch on earth, and apparently it's not going to be. All right. You might make a better sketch than I do, but that one gets the job done. It's fine. All right, we're going to see what the point is eventually. Okay, but for right now, that's good enough. Let's hurry up on the next two. Okay, let's actually do the next one together, and then we'll have you do the last one on your own, okay? So let's do this. Let's hit y equals again. Okay, let's clear out the one that we just did. All right, and now let's enter in this next one. Now I know it says negative x squared. We can put that in as negative 1 times x squared or just negative x squared. That's okay. And I'm just going to enter it the way it looks. So I'm going to hit the negative button. Don't use subtract. Use negative. Now, negative x squared plus 6x plus 1. Again, we step back. We look at the calculator. It's really important that that leading coefficient is the negative and not the subtraction. That will give you an error if you've done that. Okay? But the window is exactly what we had before, so we don't have to worry about changing it all. Okay? So let's just hit the graph button. All right. let's see if I can create a better sketch. Huh. That one opens downward. So this one opens upwards. This one opens downwards. All right. Well, how about this? Pause the video now, and you do that last one. See if you can enter it into your calculator correctly, hit the graph in correctly, all that on your own, okay? So pause the video now and put that in your calculator and graph it. All right. Well, hopefully you got a graph that looked something like this. Ugh. It shouldn't have that weirdness right here, but all right. That one also opens downward. So sometimes parabolas open upward, like in the first one, and sometimes they open downward, like in the other two. All right? So just for a moment, let's get rid of the TI-84 plus so that we can clear the screen. All right, it's gone again. Okay. Copy down anything you need to now, and then we're going to clear out the screen, and we're going to go on to really see if we can figure out what is controlling whether those parabolas open upward, and they kind of look happy, a smiling parabola, or they open downward, they're frowns, they're sad parabolas. Either way. So, pause the video. All right, I'm clearing it out. Here it goes. Okay. So in exercise 3, we're going to go graphing crazy, and we're just going to graph very, very simple parabolas. Y equals 2x squared, y equals 3x squared, y equals 4x squared, all right? Same window that we had before, okay? And we're going to see what's going on here, hopefully, all right? So let's bring that TI-84 plus right back onto our screen. There it is, all right? Let's go into y equals. Please do that. All right. Maybe we'll just do the first one together and then have you do the next two on your own, given that the window is going to stay constant. So in the first one, let's clear out what's in there. Okay. Let's put in 2 times x squared. All right. Now, unless something radical has changed, our window should still be correct. But let's take a look, because you never know, maybe you started the video right at this point. So hit the window. All right, for me, my x min is negative 10, my x max is 10. My y min is negative 10, my y max is 10. So it all looks good. Okay, check yours. Okay, let's hit the graph. All right, very simple parabola. Notice a couple things about it. All right. Most importantly, because this is what we're really trying to figure out right now, is that it's concave up. The second thing, though, I would like you to notice is that it is supposed to pass through the origin. Okay, it actually hits the point 0, 0. Okay? So, what I'd like you to do now is I'd like you to graph y equals 3x squared and y equals 4x squared. Pause the video now and go ahead and do that. Take as much time as you need. Sometimes it takes time to clear out equations, get new ones in there, hit graph, copy down your picture, etc. Anyhow, why don't you go ahead and do that? All right, let's take a look. Well, y equals 3x squared didn't look too different from y equals 2x squared. In fact, unless we have them on the same graph grid, it's actually hard to tell much of a difference at all. There is a difference, and we'll explore it in future lessons, but for right now, same deal. It opens upward, and it passes through the origin. Y equals 4x squared is more of the same. It opens upwards, and it passes through the origin. And there is a difference in the shape, obviously. They're actually getting progressively thinner, if you will. And we'll talk about that later on in a later lesson in terms of stretching the parabola. But right now, what I really want you to see primarily is that they all open upwards. Okay? So, I'm going to clear out this screen. Copy down whatever you need to. All right. I think we'll leave our calculator right where it's at for right now. No need to put it away because we're going to need it on the next sheet. All right, in fact, the next sheet looks awfully similar, except instead of having 2x squared, 3x squared, and 4x squared, we have negative 2x squared, negative 3x squared, negative 4x squared. So let's do the negative 2x squared together, and then like before, we'll have you do E and F on your own. All right, so let's hit our y equals button yet again. Let's clear out that last equation that we had in there. For me, that was y equals 2x squared. For you, hopefully, it was y equals 4x squared. But clear it out. Now let's put in negative 2x squared. Again, make sure that's a negative, not a subtraction. All right, the window is all set. I'm not going to even go into my window setting. I'm just going to hit graph. So let's do it. Ah, look what happened. Now, that's going to be like the best parabola I draw today. That's remarkable. Now the parabola opens downward. It still goes through the origin, but it opens downward. In fact, if we carefully looked at this one compared to the one in letter A, what we'd see is that they're the identical parabolas. It's just that this one, this green one from letter A, got flipped across the x-axis, to become the one in letter D. All right? Anyhow, pause the video now, take some time, put the letter E and letter F in one at a time, and sketch their graphs as well. All right. Well, you should have seen a very similar thing, right? In letter E, it also opened downward and looked identical to the one in, what was it, B, I guess, except B was up here. In fact, maybe I'll just keep sketching those because they're not on the screen anymore. Right? So this is the one from B. And then likewise, in letter F, we had quite a thin parabola, but again, passing through the origin and concave down, or opening downward. The calculus terminology for it is it's concave down. And there it is from letter C. Okay, each case, these are what are known as reflections across the x-axis, flipping the curve across the x-axis. All right, so I think we can now make a conclusion about what causes the parabola to either open upward or open downward. And it doesn't have anything to do with the B or the C in y equals ax squared plus bx plus c. So I'm going to clear this out. All right, here it goes. And I'm also going to get rid of our TI-84 plus. It's going to give it a break now, okay? Here we go. All right, the calculator's gone. Let's advance the page and do one last exercise. Really, we can summarize it, right? For the quadratic y equals ax squared plus bx plus c, all right, the parabola will open upwards. In other words, it'll look kind of like this if a is greater than 0, or a is a positive number. The parabola will open downward if a is less than 0, or if a is negative. In the case when it opens upwards, it's got a minimum y value, a lowest y value. In the case where it opens downward, it has a maximum y value. All right? And that's it. And that is really the biggest thing that we come out of today with. So let's clear out the screen, Pause the video now if you need to. All right, and let's summarize. Okay, so our second day on parabolas really amounted to one very specific thing, which is why are some parabolas opening upwards and some parabolas are opening downwards? And it all has to do with the leading coefficient. If the leading coefficient, the number that multiplies x squared, is positive, then the parabola opens upwards. And if it's negative, the parabola opens downward. Pretty simple. Now, the value of a, whether it's 1, 2, 3, 4, that will have other effects. But right now, it's just about whether the parabola opens upwards or downwards. All right. For now, I want to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking,